I'm going to be talking today about certification, challenges and benefits of certification, specifically for security hardware. And I'll talk a little bit about security and a little bit about hardware, and then a lot about certification. So let's just talk about security. Why do we need security? Connected devices obviously are more and more common in all sorts of IoT devices, and pretty much anything else you can think of is a connected device these days. All these devices need strong security. They face resource challenges, which can make implementing security difficult, but it's really necessary because the consequences of compromise of security devices can be really serious, from privacy concerns to devices being used as part of a botnet to physical devices being sabotaged or vandalized, a whole range of other threats. Looking at another domain, automobiles. So obviously we have cars that are connected, increasing amounts of driver assist and even autonomous vehicles, many different types of threats to connected vehicles, and again, a need for real strong security. So I don't think there's any argument about the need for security across these and many other domains. I talked about hardware security though. Why don't we just do what we need to do for security and software? And there are a lot of things you can do in software security-wise, but there are some real fundamental problems. Software security just doesn't scale. The complexity of software is growing rapidly. We're talking about millions of lines of code in devices, and it's really difficult to keep all of that code secure. Patching can take a long time and can be very expensive, and really only responds to threats that are known and doesn't really take care of things that may not have been developed yet. So we really need to build security into hardware to provide a foundation of security for the whole chip, for the whole device that incorporates that chip, and really for the whole system that device is embedded in. So what types of hardware security are out there? If you look at hardware security IP, there's lots of different kinds. Depending on the application, different ones may be needed. Probably the simplest is just cryptographic accelerators. So this is hardware that accelerates standard cryptographic algorithms like AES, SHA, RSA. These can have much higher performance, better power efficiency than software, and they can also be more secure because they can do things like protect keys solely in hardware so they're never actually seen by the software. As you get into more complicated IP, there are things like protocol accelerators. These are dedicated IP cores for doing things like MACsec, IPsec, TLS. Again, these can reach much higher performance levels and provide very strong security, but they're dedicated to one particular task. There's other types of application-specific IP, some things that might be used, say, for a DRM application. That's hardware that's dedicated for that specific application, meets certain performance and security requirements, but may not be very flexible. Then you have security IP that's associated with CPUs. So this is hardware that's used to isolate resources, isolate memory, and otherwise provide more security for applications running on the CPU. And many different CPU vendors provide their own security IP. And then finally, there's what is often called a root of trust. A hardware root of trust is typically a programmable solution that provides a foundation for security throughout the entire device and system. And they can perform a wide range of things, starting with secure boot, crypto acceleration, authentication and attestation, system monitoring, protocol implementations of all sorts, and so on. So a root of trust is a very powerful piece of IP that can provide hardware security for any chip. And there's lots of different places you can get hardware security IP. One possibility is just to build it in-house. It's nice, there's no license fees, but there's some real challenges and problems. One is, without having the right security expertise, it's really hard to do hardware security correctly. There's lots of things that can go wrong, and you need to get pretty much everything right, or you're going to leave a vulnerability that attackers can exploit. And there's a steep learning curve for building strong security. And also the cost to develop in-house may be quite high. You've got to dedicate resources, you have to train them, they may have to do it several times before they get it right. So it may be actually cheaper just to buy IP. There are more and more things that are available open source. And again, it's nice, there's no license fees. The security, to some degree, may have been vetted by the community. but the quality of this IP can vary quite a bit. And there's no one entity that's really responsible for making sure that the IP is secure and that it remains secure as new threats and vulnerabilities are found. And it may not work out of the box for a given application. It may need a fair amount of customization. CPU vendors sell security IP, as I said. It's often bundled with a CPU at little or no charge. Tight integration with the CPU can be quite powerful in what it does. But it's also limited to one vendor. So you're locked into the IP that your CPU vendor provides. The functionality is oriented around the CPU. So there's a lot of things that it can do, but there may be limited functionality it can do outside of the specific CPU support that it's providing. And there's no flexibility to change CPUs without then changing your entire security architecture. And then finally, you can buy security IP from a security IP vendor. And if you don't know, I'll admit that Rambus does sell security IP, so I may be a little bit biased here. But companies that sell security IP and are focused on security, we would say have the most secure and most fully featured products, and you can get a faster time to market with off-the-shelf IP. You do have to pay for it. That's the downside. Okay, so lots of places you can get your security IP. How do you know if it's any good? The reason that it's hard to know if security IP is good is that security is something that's hard to measure. You want something that's secure because you need that device that you're incorporating in to be secure. So you need something that will provide security to whatever you're building. And one simple way to think about security is just resilience. Is it resilient when faced with deliberate attacks? And there's a related concept, safety. So for a lot of applications like automotive and aerospace, safety is also really important. And safety means being resilient when faced with non-deliberate environmental disturbances. Of course, when we talk about security being resilience, I'm being a little bit simplistic, but I want to relate this idea of security and safety having some similar characteristics. And there are actually some overlaps in the techniques that you would use to provide safety and security, as well as many differences. But what's similar about these two is it's really difficult to determine whether a product is safe or secure or both without extensive evaluation, because a single flaw can result in an unsafe or insecure design. So this gets to this question of, regardless of where you're getting your security IP or building it yourself, how do you know if it's good? How do you know if it's secure? And if your application requires it, how do you know that it's safe? Well, that's where certification comes in. And there are many different certification regimes out there that attest to the safety or security of designs. Typically, this involves having a third-party laboratory evaluate the design, in some cases, the design process. They may test an actual instantiation of the product, but you're basically relying on experts to do some form of evaluation of the design and the design process. So having something certified shows that the design meets a predefined set of requirements that assure some level of safety or security, or both. A lot of certification regimes have multiple levels. So depending on how secure or how functionally safe something is, you get a different level, a score, which enables comparing different IP and different products depending on the level that they've achieved. Certification shows that your product, your IP, whatever it is, has been evaluated by experts who know what to look for, who know how to find vulnerabilities, and can provide confidence that the design has been done properly. Some certifications also show that a rigorous process was used to develop the design. They look at not only the end result, but also the process that was used to develop it. So were proper controls put in place to make sure that security requirements were met? Are there rigorous processes in place as part of the overall development cycle, and so on? Another benefit of certification is it may be needed to show competitiveness with other products in the market. If a competitor has reached some level of security or safety certification, it may be necessary really to compete with them. And it also may be required for sales to certain customers. So in particular, government entities may require some specific certifications to even be considered for the sale. So lots of benefits of certification. Like everything, there are some challenges and drawbacks. So getting a design certified presents some real challenges. Test labs have to be paid for certification. This can be expensive. The certification process requires work by engineers to document information, organize designs for review. It can be very time consuming, so costly in that way as well. If you're designing something without certification in mind, you may have some surprises and find that you need to make costly changes to meet the certification requirements. So it's good to think about certification up front as you're beginning the design process. And also some certifications, like I said, look at the actual development process. And if you have to change your development process, that can be very costly and disruptive to the work that you do. Certification is particularly challenging for open source designs, where there's really no one entity that's responsible for the design, and there may be no one who's willing and able to actually pay for the certification. So let's look at some of the certification regimes out there and what the benefits that they offer and also some challenges. So one specification that often comes up is from NIST, the US National Institute of Standards and Technology. They have a security standard called FIPS 140-2. It's usually required to sell to US government customers and an increasing number of commercial customers. Also, commercial customers who sell to the government may want to have their products certified, even if they sell them, in some cases, to entities that don't require the certification. It's easier to have one version that meets the certification so they can sell it to the government. And then part of FIPS 140-2 is what's called CAVP, and it's a certification standard for designs implementing cryptographic algorithms. So it basically validates that these algorithms are implemented correctly. So they look at the operation of the design on known data and make sure that the correct outputs are put. So it's pretty simple and straightforward. It's just showing that these cryptographic operations are implemented correctly. And it's looking at the values that are produced, basically, and not the implementation itself. Certification is done by approved test labs. NIST maintains a list of certified designs, so people can look on the NIST site and see if you've been certified. And then there's FIPS 140-2 CMVP, which is a certification standard for more than just the cryptographic operations. It's really for an entire cryptographic module that provides security functions. So it looks at the security functionality and the implementation of that functionality, not just the cryptographic operations. And it has 4 levels, from level 1 to level 4. Level 1's the lowest, level 4 is the highest. So things are certified to CMVP, level 1, level 2, level 3, level 4. So you can make a comparison between different designs that may have reached different levels. The evaluation, the certification process is much more involved than CAVP because you're looking at not just a simple cryptographic operation, but you're also looking at the implementation and a whole range of security properties. Again, certification is done by test labs, and NIST maintains a list of certified designs. NIST is actually updating FIPS 140 to FIPS 140-3. It was published in March of this year. Testing will begin in September of next year. They'll continue testing at FIPS 140-2 for at least an additional year. And one thing that's new, and there's a lot of new things which I can't cover, we actually have a whole presentation that talks about the differences, but one is reference to ISO 17825, which talks about mitigation of non-invasive attack classes. So this is a whole class of attacks that weren't considered as part of FIPS 140-2, side channel attacks like differential power analysis and other attacks that now will need to be considered under FIPS 140-3. So the FIPS labs are still trying to understand all the details, all the new security requirements. Going through FIPS 140-3 will be a little painful, I think, at first as they work out all those details. So I think a lot of vendors will continue to certify under FIPS 140-2 while they still can, but people should know that this new standard will be required for lots of different types of entities and sales, and it will be more rigorous and harder to get the certification complete. There's a functional safety standard called ISO 26262, and it's basically showing that components that go in automobiles are safe. In other words, they're resilient to environmental disturbances, and they'll continue operating correctly even if there's some sort of fault or glitch or abnormal environmental operational characteristics. There's some overlap with security, so an attack may actually look similar to an environmental fault. Someone could be trying to glitch something as an attacker, but you also could get just glitches on the electrical system due to some other malfunction. So there are different levels with ISO 26262. They call them automotive safety integrity levels from ASIL A to ASIL D, with ASIL D being the highest safety level for safety critical things like brakes and steering and so forth. In addition to specifying the functional safety itself, it also does look at the processes that are used for development. And certification under ISO 262 is required for most sales and components to be used in automobiles. There's a new certification spec, ISO, it's a joint spec between ISO and SAE, 21434, which is a automotive cybersecurity spec. So not looking at functional safety, looking at actual security. It defines a very structured process to ensure that cybersecurity is designed in upfront. So making sure that security is thought about from the beginning of the design process and not just added in later. It's been in development since 2016. Latest information I've seen, it's expected to be released in late 2020. This will have a very big impact on security in automotive. It'll be the first really comprehensive spec out there. And it is expected that compliance and certification will be required for future sales of any component that has security implications in automobiles, and more, that's pretty much everything. Another one that people have often heard about is common criteria. Serves in some sense the same purpose as FIPS 140. It started largely as a European effort, but it's now used worldwide. This also has different levels, the evaluation assurance level ranging from 1 to 7, and 7 being the highest. So common criteria shows up in mobile systems quite a bit, also in financial networks, where there are specific requirements to meet an assurance level of EAL4 plus or higher. So it is a widely used common standard, but it's also fairly complicated and expensive. So companies typically won't go through the trouble unless they're selling into a particular market where it's necessary. Okay, so that's just an overview of some of the different certification regimes out there. Rambus believes in certification. We say it is very important to assure quality in our products, both for safety and security, and also assuring our customers that what they're getting is something that will meet their needs. We do provide a range of security IP, cryptographic accelerators, application-specific IP, root of trust IP. All of our cryptographic accelerators are certified under FIPS 140-2 CAVP. We have test equipment called the Rambus DPA workstation that can test for resistance to many of those non-evasive attacks that are referenced in ISO 17825, which is part of the new FIPS 140-3 standard. So we can test and make sure that things have the proper resistance to meet that standard. Our CryptoManager root of trust, which is our hardware root of trust IP, has been evaluated under 140-2 CMVP, and we expect that certification to be complete next year. We have an automotive version of the CryptoManager root of trust that we've designed for ISO 26262 ASIL D compliance. So that's the highest level, again, of functional safety and certification. Completing the certification process is ongoing. Our cryptographic accelerators have been integrated into products certified to common criteria EAL4+, so they meet all those requirements. We're also currently planning for FIPS 140-3 certification as that's finally been released and defined. And once the ISO SAE 21434 is out, we'll evaluate that, and I'm sure we'll make sure that we meet those requirements as well. Because again, we see, again, challenges and costs associated with certification, but there's some real value not only to companies producing security IP like ourselves, but also to companies who are using security IP. So with that, I finished with 13 seconds left, so I timed that pretty well. But maybe we can squeeze in a question or two if there are any. Okay. Thank you. Yes? I mean, that's possible. There's a lot of thought about what sort of regulation may be necessary for IoT devices. Lots of governments in lots of different parts of the world are at least considering some sort of requirements for IoT device security. And it's hard to mandate that without being able to point to some specific certification regime and say, okay, we're mandating that by such and such a date, every IoT device will need to be certified to this specific standard. So it's possible. We'll wait and see what happens. There's definitely the need for stronger IoT security being used across the board, though, no doubt. Yep. What's the UN's role in IoT security? That's a good question. I'm not aware of anything that they're doing in that area. It's an interesting thought because there are worldwide security implications. Yeah.
If you have IP that's certified, does it have to be recertified at every instance in every case?
Great question. So certification can be done by an IP, but it also, in most cases, needs to be done on the device that incorporates that IP. So if you're producing a chip and you need to get certification, if you buy IP that's already been certified, you don't need to go through the certification process for that IP, but your chip will need to be certified. So if you're changing things in your chip design, even if the IP stays the same, some degree of recertification may be required. Now, different certification regimes have different requirements for when is a full recertification needed, when can you do an incremental certification on things that have changed, varies in the type of device and the type of certification regime that you're going through. In the back, yeah. Yeah, so the whole product consists of both hardware and firmware, and that whole product is compliant and will be certified under FIPS 140-2. You really have to look at the entirety of the IP and get the entire thing certified. Okay, I don't see any other questions. I'll be up front for a while if you want to come up and have any additional questions. So thanks so much for your time and attention. Appreciate it.